Hi folks, I'm going to help you with section 4.4 number 73, that Ferris wheel problem. Let me just switch to actually reading it so you know which one I'm talking about. It's this one right there where it says a Ferris wheel is 50 feet in diameter, makes one revolution every 40 seconds. If the center of the wheel is 30 feet above the ground, how long after reaching the low point is the rider 50 feet above the ground? So once you hit the low ground, how long does it take to get to 50 feet is what it's asking. So let me just go back to knowability here. The first thing I'm going to do is, what I did do was draw an axis, and instead of an XY, I'm going to have it as time versus height. And I know that the middle of this wheel is at 30 feet, so I'm going to right now do a midline here at 30 feet. So this is my midline at 30 feet. And I know that the wheel itself is 50 feet. So if this 30 feet is the midline, that I'm going to have a max of 30 plus the 25, which is the radius of the wheel. And that's going to give me 55 feet. That's as tall, that's as tall as you're going to be getting if you're on this ride. So 55 feet tall. And then 30 minus that 25 is going to give me a minimum. Ooh, my picture's not very good. I can do a little bit better here because you'll see what I'm talking about here in a minute. Because this is 5 feet. And this is that midline again at 30 feet. Okay, so the difference here is 25 feet, and the difference here is 25 feet, which accounts for the 50-foot diameter Ferris wheel. Okay, so now let's just kind of draw a picture in here just so you can kind of see what's happening. You're going to start, because cosine is the easiest one to use when you're dealing with a story problem, and especially since you're not starting at 0, 0, because you have to be 5 feet above the ground even to get onto the Ferris wheel ride, and then it starts rotating up to that highest spot and then coming back down. So if you've ever been on a Ferris wheel, you know you have to walk up a platform to get to it. So it's going to not be at 0, 0. We're actually talking about right here is 5 feet, and then this is 55 feet. So you actually go 55 feet tall. Okay, so I'm going to have a max here of 55. It's going to come down. It's going to be at the minimum, which is 5 feet, and it's going to come back up, and then it's going to continue that over and over again. But that's just one cycle right there. So again, we know this is 55 feet down to 5 feet, and then back up. And we know this happened in 40 seconds, and we know that because they said one revolution is 40 seconds. So I know this is 40, this is times 0, the halfway mark here is 20 seconds. So these are all seconds and seconds. So right now I could pretty much give you a pretty good function. So let me just kind of change it. Well, I don't know, I can do it in red, I suppose. We have y equals, the amplitude we know, the a value is 25, cosine, my period is 40, so I need to change that over to frequency. So I know that the calculation is period equals 2 pi divided by the frequency. And if the period is 40, you can substitute that in and do a quick calculation, multiply both sides by b, divide out. You end up with a b value of 2 pi over 40. And I'm not going to simplify it just because I want you to be able to see it and be okay with that. So obviously you can simplify that down to pi over 20, but I just want to kind of leave it there just so that it's very obvious. T. Now, I do need to shift this because if you remember what the problem said, it asks you how long it takes to go from the minimum point up to that 50 feet. And if you notice that this is starting at the 55 feet. So I really want to shift this. And this is the part that sometimes I lose students. So I just want to make sure I'm clear on this. I want to shift this minimum point over here so that it is right here. because if I have that, then I know that's the starting point, which is a minimum, kind of like when you get on the ride, and then you go from there. So I'm going to shift this whole thing left 20, which means I'm going to add 20 seconds. And then, I could leave it in black, I suppose, but plus to get up to that midline or the vertical shift is 30. So this right here, what I just did, is really the main part of this problem, is to be able to create this function. And everything is all playing into each other to be able to come up with this. So this function represents going on this Ferris wheel ride and oscillating between 5 feet and 55 feet with that midline at 30 feet. Now, that still doesn't answer the question, but here's what you do. You want to find out when your height, which is the y, is 50 feet. Now, you can put 50 feet in for y, substitute it in, and solve for t. That is a beast of a problem, mathematically. That's why we have graphing calculators. So you could put your function here that's clouded into your y1, this other, what you're trying to find, into your y2. This should this should be coming back from what we've done many, many times, and find that intersection between those two, which is your solution. And you'll have many intersections, but really we're looking at the first time it gets to 50 feet. So let me show you, because graphing calculator can't be done on the iPad, I'm going to show you, now before I say this, make sure you can type this function into your graphing calculator, because that's half the battle. So even though I'm using Desmos, which makes it very much easier, make sure you can get the same graph on your graphing calculator, because that, like I said, is a little bit of a challenge. This here, you notice the red line, or curve, excuse me, is my cosine function that we just calculated or created. Then y equals 50 is the blue intersection. I adjusted my scale so that it makes sense. And what you notice, hopefully, is that it starts here, down here at this point of 0,5, which means time 0, 5 feet above the ground. We start going up on the Ferris wheel, and at this point right here, 15.9 seconds, we will be at 50 feet. Notice up here, we at 20 seconds, which makes sense because we know the whole period is 40. 20 seconds we'll be at that max height of 55. Then we come back down 40 seconds later to be right back at the beginning, and then we can do it all over again, but we don't really care about that because the problem was just that we are interested in knowing when the first happens. So the answer to this problem, the intersection, is going to be, or the first time it gets from 5 feet to that 50 feet, is going to be 15.9 seconds. It's an awesome problem, and it's something that you definitely can do. So once you've heard my video, try it on your own, work it through, and try to get it straight. Come in with some questions, and we'll go from there. Thanks for tuning in.